All right, so here's the second part of section 7. So we're going to be graphing a circle. But we're going to have to do that completing the square thing. Within this problem to do that. So we get this big old long like equation. So the first thing that I want to do is I want to get rid of this number that's just kind of by itself. So I'm going to have 16 over here. And then I'm going to also just kind of reorder things. I want the 8x to be with the x squared, and I want the y squared and the 4y to be kind of with each other. And it's plus y squared, so I could put a plus there. So now we need to do that completing the square thing to help us out here. So, I already moved the c term kind of at the beginning when I put that number over there on the right. You're not going to have a divide by a, so you won't have to worry about that. I'm going to do this half the b term. I'm going to end up doing it twice because there's an x part and a y part. So half of 8 is 4. 4 squared is 16. So I'm going to add 16. Okay, and then I'm going to do it again over here with the y part. Half of 4 is 2. 2 squared is 4. And I'm going to add that to both sides. Okay, then I'm going to factor just the x part. So just this x squared minus 8x plus 16. So that's, remember I said square root of 16 is 4. So this one's going to be x minus 4 squared. Minus because the 8 is minus. Okay, and then I'm going to do the same thing over here. Square root of 4, the green 4, square root of 4 is 2. So y plus 2, it's plus 2 because the middle 4 is positive, squared. And then I'm going to add all that stuff up. 16 plus 16 is 32, plus 4 is 36. Okay, so now I have the equation of a circle. So the center is 4, negative 2. So remember, it's because the formula is minus. It's like x minus h squared plus y minus k squared. That because of those minuses, the center is actually the opposite of what you see. So this, I see negative 4 in here, so it's positive 4 down for the center. I see positive 2, so the center is actually negative 2. And the radius is 6. So remember, this 36 over there, that's r squared. Okay, so I want just r, so I have to do the square root. Okay, so to graph the circle, it's kind of like, can be difficult, but 1, 2, 3, 4, negative 2. So then what I do, radius is 6. I'm going to go 6 in each direction. 1, 2, 3, 4, 5, 6. 6 to the right, 6 to the left, 6 down, 6 up, and then that there's kind of like I can make my best I can circle. Okay, so gotta do that completing this square like deal. Now if let's check thinking the ones you're going to have to do, it looks like all of them, the radius works out. Yeah, they do. The radius works out to be a whole number. So could have one that looks like this. And this is a little bit more straightforward because the number is like already over there, like on the right hand side. So we don't want like any just numbers over here on the left side. So this one that doesn't have, oh, I meant to put 6, or doesn't have anything that's just a y. So when I reorder them, again, I want to leave the space to do the Pythagorean, or not Pythagorean theorem, but the completing the square. There's nothing that goes with the y, so I'm just going to put it like that, and I'll come back and address that in a second. So half the b term is, half of 6 is 3, squared is 9. Okay, when I factor this, square root of 9 is 3. Why did I put a 0? Well, I do know why I put a 0. I was thinking ahead, but 2. So it's okay if we just have y squared and nothing else to go with it, because that just means it's 0. So the center is -3, 0 for the y part. If there was just x squared and no whatever x to go with it, then the x part of the center is just 0. And then our radius is 4. So when we go to graph it, -3, 0. And then again, I'm going to go 4 in all directions. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. And then again, it's kind of hard to draw these like perfect. Oh, that one's actually not too bad. Just remember, make an arc. You're not drawing lines, you'll look like a diamond. So just do the best you can. I'm not going to go crazy with how these look. Oh, it's not a perfect enough circle. Like, that's not going to happen. Okay, but I do need to see like what's written right there. If I just see like the graph and nothing else, then I'm going to think you copied and I'm not going to give you credit. So please write your stuff down. All right, then the other thing that you're going to have to do is, it's going to say, like, I might even use the word prove. Prove or disprove the statement. So we could have something like this. The point 3, 4 lies on a circle with center at the origin and a radius of 5. Okay, so it's actually not a super difficult problem. So if I had, a circle with the center at the origin, and I'm saying, like, I'm going to either prove that 3, 4 is on the circle or it's not. So if I have some circle drawn, the radius has to be 5. So from the center to the edge of the circle has to be 5. And so what we're doing is we're just creating a triangle, 3, 4, and I want to, like, is the blue part a radius of 5? And so you might, if you remember, that's a 3, 4, 5 triangle, so we're actually good. But you're just doing 3 squared plus 4 squared square root of 25 equals 5, so we're good. Okay, so you're just testing the Pythagorean theorem out, basically. Okay, now it's going to involve a couple of them, some square roots. So 2 problems like this, where it says the point, and it gives you a point, lies on a circle with the center at the origin and a radius of blank. So then you're just going to kind of do the Pythagorean theorem with that one point and see if it matches. And then you'll have 2. Let's kind of talk about that briefly. And I'm going to kind of change the way that the problem is set up. So it says the point square root of 2 square root of 3 lies on a circle centered at the origin and contains the point -3, 1. Or something like that. Okay, so this one is a little bit like different in that I don't know a radius, but if this point square root of 2 square root of 3 is on the circle, I can figure, and because it's centered at the origin, so that's like a huge like help. And all your problems will be centered at the origin, so that's a very big help. So if I can figure out the radius of this -2, -3, or excuse me, square root of 2 square root of 3 point, I could also figure out the radius of -3, 1. And then I can see if they match. So you don't need to really draw necessarily like the coordinate, but, and some of you might be going like, well, how the heck do I graph -2 or square root of 2 square root of 3? Honestly, it doesn't matter, because I'm just going to go some distance to the right, and I'm going to say that that's square root of 2, and then I'm going to go some distance up, and I'm going to say that's square root of 3. It's more than 1, it's less than 2. Square root of 4 is 2. Square root of 1 is 1. So it's in between 1 and 2. But I really don't need to necessarily know that, because that's the A and the B part for the Pythagorean theorem. So if I do square root of 2 squared plus square root of 3 squared, remember a square and a square root cancel each other out. Okay, and then I would actually, then I need to do the square root of 5 is the radius. So I have to do the square root at the end of that. Because remember, this is like c squared. Okay, so I need to do the square root of 5 at the end. So then I just kind of do the same thing like over here. Like it's -3 to the left and up 1. You know, and I see if that one works. So I -3 squared plus 1 squared, 9 plus 1 is 10. And so the radius of this one would be -10. So this one, I think more so like it doesn't work. Okay, so you'll have problems where it says I have this point that's on the circle and this point also. You need to actually do the Pythagorean theorem twice and see if they match. Okay, so you'll have like 4 or 5 five graphing problems, and then you'll have a few of these. Okay, all right. Have a great Monday, and we'll see you tomorrow.